On this worksheet, we're going to look at solving compound inequalities. And notice the directions says show all work to receive full credit, and then you're going to use your own paper. There's not enough room here to show the work for some of these problems. All right, so number one, we have this compound inequality. So I'm going to go ahead and rewrite it here. So we have number one is -1 is less than or equal to 3x plus 5, and that's less than 8. So notice that this compound inequality, what makes this a compound inequality is that you'll see that the statement here has two inequality symbols associated with it. So that's a compound inequality. So what you're trying to do, though, is find the values of x such that when you multiply that value by 3 and add 5, that value here will be less than 8, and at the same time, notice how I use the word and, at the same time, is going to be greater than or equal to a -1. Okay, so that's what that's asking you to do. So we have -1 is less than or equal to 3x plus 5, and 3x plus 5 is also less than 8. So the best way to solve a compound inequality that looks like this is to get the variable x in the middle. And so if this part wasn't here, then we all know how to solve this simple linear inequality. You're going to, since I'm adding 5, you're going to subtract 5 from both sides, right? Well, there are 3 parts here. There's the left-hand side, the middle part, and the right-hand side. So we're going to have to subtract 5. That's a 5 here. We have to subtract 5 from all parts. All right, combining like terms, I have a -1 and a -5 is a -6 is less than or equal to 5 and a -5 are opposites. Those add up to be 0. And so you get 3x in the middle is less than 8, and a -5 is a +3. And then let me go ahead and just rewrite this over. All right, so remember, we're getting to the point. See, all these are equivalent expressions here, or equivalent inequalities. And so what I need to do now is to get the variable x in the middle. So right now I'm multiplying x by 3. The opposite is to divide by 3. But what I do here, I have to do to all parts. Okay? And then simplifying, -6 divided by 3 is a -2. Is less than or equal to 3 divided by 3 is 1. 1 times x is x. And that's less than 3 divided by 3, which is 1. So I found the solutions to this original compound inequality. The solutions would be any real number, rational or irrational, that is between -2 and 1. Notice there's an equal sign here, meaning that -2 is a solution, and there's no equal sign here, meaning that 1 is not a solution. But any real number between -2 and 1 will be a solution to this original compound inequality. So when you look at this in terms of a graph, so when you're asked to graph this, I'm going to just put the solution here. So the solution, remember the work's going to be on the next page. So the solution is -2, it's less than or equal to x, it's less than 1. So that's the solution to this compound inequality. So to graph this though, so here's -2 right here. Notice there's an equal sign. So -2 is a solution. So we're going to put a closed circle or a bracket. So I'm just going to go ahead and use a closed circle here. 1 is not a solution because there's no equal sign, so I'm going to put an open circle. But remember, you have to shade in every real number that's between -2 and 1. So there's your graph. In interval notation, you always go from smallest to largest. You always go from left to right, smallest to largest. -2 with a closed circle corresponds to a bracket. So you got to put a bracket here, -2, all the way to 1 with parentheses. The open circle corresponds to a parentheses. All right, so that was number 1. Now what I want you to also notice is that we could have also, I'm going to go ahead and show this, we could have also used a second approach here. And remember when we read this, we said -1 is less than or equal to 3x plus 5, and, notice I'm using the word and, 3x plus 5 has to also be less than 8. So some students, when seeing a compound inequality like this, they prefer to write as an and statement. Most students don't. Most students will do what we just did. But this is really an and statement, not an or statement, an and statement. And so if I solve each one individually, let's go ahead and subtract 5 from each side, and I get -1 and -5 is a -6. Is less than or equal to, this is 0, 3x. Notice this negative 6 corresponds to this negative 6. And then divide both sides by 3. I get negative 6 divided by 3 is a negative 2. Notice that negative 2 corresponds to this right here. It's less than or equal to, and then 3 divided by 3 is 1. 1 times x is x. So any real number, now remember this right here, negative 2 is less than or equal to x, means the same thing, or is equivalent to the inequality x is greater than or equal to negative 2. Over here, if I solve this simple inequality, subtract 5 from both sides, I get 3x, this is 0, is less than 8, and the negative 5 is a 3. So notice this 3 corresponds to this 3 right here, And then if I divide both sides by 3 and simplify, I get 3 divided by 3 is 1. 1 times x is x is less than 3 divided by 3 is 1, and that 1 corresponds to this. But remember, in a little while, you're going to solve an and statement. We're going to solve this one in a little while. But remember, when you do an and statement, you're looking for the intersection. So we're going to be looking for the intersection of these two inequalities. So on the number line, let's go ahead and graph these individually. So if I look at this one first, here's negative 2, closed circle, going to the right. Okay? And then 1 is to the right of negative 2. Make sure you put that correctly. There's no equal sign, so it'll be an open circle going to the left. X is less than 1. And remember, the intersection, so we're looking to see where those two graphs overlap. And so my final graph will be from negative 2, closed circle, all the way to 1, open circle. And I'm going to shade in everything between. Make sure it looks like you're shading. All right, so make it darker. And so that's it. So that's the graph of this, which is what we did here. All right, and then interval notation, you're basically going to say bracket negative 2, always go from smallest to largest, 1 parentheses. All right, so that was the second approach. The second approach was to rewrite this as an and statement. Most students don't, but if you do, just make sure you write as an and statement. You put the word and because that's the intersection. Okay, number 2, let's look at number 2. So number 2 is similar to number 1, except we have to use another property that we've learned. All right, so let's look at number 2. So number 2, we have negative 11 is less than negative 2x plus 1 is less than negative 5. All right, so we're going to go ahead and to solve this compound inequality, we're going to go ahead and get the variable x in the middle, so that will tell us right away what the solutions are. So we're going to subtract 1 from all 3 parts. A negative 11 and negative 1 is a negative 12 is less than, this is 0, and negative 2x and 0 is a negative 2x is less than negative 5 and negative 1 is a negative 6. All right, now, here's where you got to remember something. So let me go ahead and rewrite this over. I'm just rewriting this compound inequality, this equivalent statement over. All right, at this point, you got to get x by itself. So we're going to go ahead and divide all parts by a negative 2. That's the coefficient of x. But remember, whenever you multiply or divide both sides, or in this case, all parts of an inequality by a negative number, you must reverse the inequality symbol. So this right here, you've got to reverse. So this becomes greater than. And so now negative 12 divided by negative 2 is a negative 6 is greater than negative 2 divided by negative 2 is 1. 1 times x is x is greater than negative 6 divided by negative 2 is a positive 3. Now, remember though, when, and this is a correct statement, but remember, we tend to go from smallest to largest, right? So, oops, I think let me make sure I didn't do anything wrong here. Let's see. All right, so right here I made the mistake. I knew something was wrong because this number has to be bigger than that number. A negative 12 divided by negative 2 is a positive 6. All right, good. So I figured out that there was an error there. So be careful as you go along the way. You could easily make an error. So always double check. Okay, now what I was saying though is remember we tend to rewrite this from smallest to largest. So let's go ahead and rewrite this in a different form. This right here is equivalent to this. So remember, x is greater than 3 means the same thing as saying 3 is less than x. Okay? Negative 6 is greater than x. If I cover this part, positive 6 is greater than x means the same thing as x is less than 6. So basically, you're just rewriting this backwards. So 3 is less than x, it's less than 6. That's what we wrote here. And so now when you write it like this, it makes it, and I'm going to go ahead and go to the graph here. It makes the graph a lot easier to deal with. So remember, let me write the solution here. 3 is less than x, is less than 6. That's the solution, right? Here's your work right here. So make sure you show the work. That's the solution. And so here's 3. Notice there's no equal sign in any part, right? So it'll be an open circle. So here's an open circle on 3, an open circle on 6, and make sure you show this thing is being shaded. All right, so it's got to be shaded. And then in interval notation, always go from smallest to largest. So parentheses 3, 6 parentheses because both of those are open circles. All right, and number 3 is an or statement. So let's look at number 3. So here's number 3. We have 2x minus 1 is less than 5, or 3x plus 1 is greater than or equal to 17. All right, so remember, this compound inequality has an or statement. All right, and basically what you're saying is this: the solutions to this compound inequality will be solutions to this or this, not both, but to each one. So whatever the solutions are here is a solution to this whole thing. Whatever the solution is here is a solution to this whole thing. Okay? So that's what you're finding. So the or means union. So you're looking at the union of those two solutions. Okay, so let's go ahead and solve each one individually. So we're going to add 1 to both sides here. So I get 2x, this is 0, is less than 5 and 1 is 6. Divide both sides by 2 and simplify. 2 divided by 2 is 1. 1 times x is x. It's less than 6 divided by 2 is 3. So what I found is this. The solutions to this linear inequality here is any real number less than 3. But remember, that's an or statement. So that is also the solution, well, part of, because we have to look at this one too, but that's also part of the solution to this compound inequality. There could be more depending on what we see here. All right. All right, over here, let's go ahead and subtract 1 from both sides. I get 3x is greater than or equal to 17 minus 1 is 16. Divide both sides by 3 and then simplify. I get x is greater than or equal to 16 thirds. Or if I want to, I can say x is greater than or equal to, I can write this as a mixed number. So that's going to be 5 and 1/3. All right. Okay, so what I found here, any value of x greater than or equal to 5 and 1/3 is a solution to this linear inequality. But since that's an or statement, it's also a solution to this compound inequality. All right, but we got to write the solution better. So here's the way you're going to do this. So let's look at each of the solutions individually. So here's 3, open circle going to the left, right? X is less than 3. And then 5 1/3 will be to the right of this, 5 1/3. Closed circle because of the equal sign going to the right. Now, remember, this is an or statement. So anything that's shaded is a solution. Anything that's shaded is a solution. So the solution to this compound inequality will be this set here and also this set. But you got to write it better. So the graph, you got to put this on one number line. Don't leave it like this. Put it in one number line. So here's 3, open circle going to the left. Make sure you put the arrow. Here's 5 1/3 or 16 thirds. Closed circle going to the right. Make sure you show the arrow. So there's the graph. So when I put it here, though, let's go ahead and write it a little bit better. So the solution, your solution as an inequality will be x is less than 3 or x is greater than or equal to 16 thirds. All right, so over here, let's see where this is going to be located. This one's easy. So x is less than 3 is right here. Make sure it looks dark, and there's an arrow here. And then 5 1/3 is between 5 and 6, but closer to 5, right? So and that's a closed circle, so we put a closed circle here. and then going to the right. And so there's a graph. All right, let me make this closed circle a little bit darker. All right, interval notation. Remember, you always go from left to right. Notice the interval notation, there are two parts. So you go from negative infinity to 3. And remember, whenever we use negative infinity to infinity, it's always parentheses. 3, parentheses because of the open circle. Union, so remember, the R means union, right? So union, and then bracket 5 and a third to infinity. All right, so that was number 3. Okay, let's go to number 4. Number 4 is an and statement. Remember, and means intersection, right? Intersection. Okay, so let's look at number 4. So here's a problem. We have 4x plus 2 is less than or equal to 14, and 2x minus 1 is greater than negative 13. Now remember, this compounding inequality has an and statement. So what that means is this. The solution to this compound statement has to be the solution where those two intersect. Okay, so that's the intersection. The solution to this compound has to satisfy this one, and at the same time, it has to satisfy the other one. So that's the intersection. But we're going to solve each one individually. So we're going to subtract 2 from both sides to solve for this one. And so I get 4x is less than or equal to 12. Divide both sides by 4. And then simplify. I get x is less than or equal to 3. So the solution to this linear inequality here is any real number less than or equal to 3. All right? But remember, I'm trying to solve this compound inequality, so I got to see if any of this overlaps with any of these solutions, because that's the intersection. So over here, we're going to add 1 to both sides. So I get 2x is greater than negative 13 and 1 is a negative 12. Divide both sides by 2, and then simplify. I get x is greater than a negative 6. All right, now remember, that's an and statement. All right, so what I have so far is this. I have in terms, so solution, well, I'm just going to go ahead and rewrite what we have here. So the solution so far is this. X is less than or equal to 3. And at the same time, let me show you. And at the same time, x is greater than negative 6, right? Okay, but we got to write this better. So you're going to draw each one individually, just like we did with the or statement. So x is less than or equal to 3. So here's 3. Closed circle because of the equal sign going to the left. And then below it, we have negative 6, which is to the left of 3. Open circle going to the right because x is greater than negative 6, right? And so since this is an and statement, we have to look at where those two graphs intersect. And so they intersect, so this would be the graph you would show. So they intersect from negative 6, open circle, to a positive 3, closed circle, right? And then shade in everything between them. And so that would be the graph. And so we're going to go here now, and we're going to draw the graph. So it'll be from negative 6, open circle, to a positive 3, closed circle, and then shade in everything between them. And then the interval notation always go from smallest to largest. So we go in parentheses negative 6 all the way to 3 with a bracket. All right? So that is the key to the worksheet on solving compound inequalities.